So today we're going to be talking about something called limiting reagents, and we'll talk about what that is in just a second, but it's going to tie into this problem right here. So let's just do the Stoic. Super simple. Your starting number is 100 grams of S, and S is not a metal, so I don't know why it says metal, but 100 grams of S, and it's going to react with excess Fe. Okay, so since we have excess Fe, we don't need to worry about the iron when we do our problem. And we're going to be solving for the theoretical yield of FES. So basically it just means do some Stoic. All right, so our starting number is 100 grams of sulfur. And so we're going to set up our three fractions. So like I said, we're just going to be doing Stoic forever. So just make sure you guys follow along and you know how to do it. We're looking for FES, so that's what we're going to end with. We're going to end with grams of FES, and then we're going to have gamamaga. So grams, moles, moles, grams. I'm going to go through this kind of quickly just because we have so many videos already and problems that we did with Stoic. So I'm going to speed through a little. So if you have any questions, let me know. First two fractions about the same chemical, and the last two fractions are about the same chemical. And then if you guys remember, the numbers for the first and the third fractions come from the molar mass. And the second one comes from the balanced equation. Okay, first fraction, the bottom is going to be grams of S, so we can cancel it out. Molar mass of S, since it's just one element, we can just go on the periodic table. S is on the top right. It's going to be 32.07. But since the 10th place is a 0, we can round that down to 32. So it is going to be 32 grams per 1 mole. And these cancel. Okay. Next, we're going to put moles of S on the bottom. If you guys notice, there's nothing in front of S and nothing in front of FES. So we can just put a 1 in front of both. And so moles cancel out. And then last but not least, we're going to put moles of FES on the bottom. Molar mass of FES, we just need to add 32 with whatever Fe is. So if we look up Fe, middle of the periodic table, it's 55.84. So you can just put that into your calculator, 55.84 plus 32, 87.84. So the molar mass of FES is 87.84 over 1. They cancel. And now all we need to do is plug it into the calculator and we're all done. Okay, so at this point, just to be honest with you guys, you should be able to do this no problem. That's why I'm going through it pretty quick. But if you guys are still having trouble, just make sure that you guys check the older lectures and your notes and get some practice in, okay? All right, so the final answer is 274.5 grams of FES. Any questions about that one? Hopefully the Stoic is pretty easy. Yeah, what's up? Huh? 274.5 grams of FES. All right, so just make sure you guys have that number down because we're actually going to come back to that in just a bit. But one thing I do want to mention as we go on, this is the old stuff that we're reviewing. Now we're going to add one more thing onto it, okay? So if you guys notice, every time we have a chemical reaction, we have one starting number, right? We have a starting number and then we have excess of something, right? You guys probably have noticed that by now. But today what we're going to learn is what do we do when we have two starting numbers? So instead of excess, what if we had 100 grams of Fe? Then we have two different starting numbers. And so that's what we're going to be talking about today. What to do when you have multiple starting numbers. Because when you do a lab, sometimes you don't have unlimited amounts of one of them, right? You have limited quantities of both. And so you need to figure out how much your theoretical yield is going to be when you have multiple starting numbers, okay? Okay, so let's get started with the new information. So you guys don't need to copy down this. This is just kind of to help us visualize what's going on. So what I want you guys to do right now is just kind of look at this reaction up here. Don't copy it down. It's just here to kind of help us understand. Okay, so we have a chemical reaction for a hot dog. Pretty easy to make one, right? You get one sausage, one bun, and you get a hot dog. Probably not the best tasting one. You need some condiments on there, but this is a general outline. Why are you shaking your head? Do you make your hot dogs a different way? Gee, you're gross. Okay, but anyway, Hot dog is one sausage, one bun makes one hot dog. Okay, so let's just kind of use this as our blueprint for figuring out what limiting reagents are. Okay, so if you have 3 sausages and excess buns, I want you guys to show me with your fingers how many hot dogs can you make if you have 3 sausages and 1 bun. Show me with your fingers. How many can you make? If you have 3 sausages and excess buns. Excess meaning you have so much you don't need to worry about it. Yeah, it's gonna be 3, right? West side. You're gonna need to make three hot dogs because. So if you have excess buns, all right. I know hot dogs really excite you guys back there, but let's keep it down. Okay. Okay. Whatever. Okay. So your theoretical yield is gonna be 3 hot dogs, right? Because once you make 3 hot dogs, what do you run out of? You run out of sausages, right? Yes, so you run out of hot dogs, but once you make 3 hot dogs, you use all your sausages, right? And the only thing you have left over are the buns, and you can't really make another hot dog because you've already used. Yes, you do have too much buns. Okay. Anyways, you guys are way too happy to talk about this. Okay. So we're gonna be talking about what the limiting reagent is. So make sure you guys write this definition down. But limiting reagents are the reactants that runs out first. Okay. So whatever reactants runs out first is going to be your limiting reagent. So as we do our stoichiometry problems and whatnot, you're going to have to figure out what the limiting reagent is. Let's just make sure you guys jot that down. We're actually going to come back to that definition in just a second. Okay, so in this situation, we already said that we run out of the sausages first, and so that is going to be our limiting reagent. Okay, so the limiting reagent here is going to be the sausage. Whatever you run out of first is what we call our limiting reagent. Okay. My goodness, guys. Is that word that funny to you guys? Sausages. I don't know. You're the ones giggling like crazy. So I don't know if sausages make you happy, sure, but. Oh, buns. Okay. That's fair too. Okay. So one thing I do want to point out before we move on is that limiting reagents are always going to be reactants. Okay, if you guys remember, reactants are the chemicals that we have on the left side of the arrow, and the stuff that we have on the right side of the arrow are called products. Whenever you're asked to find the limiting reagent, make sure you guys write down a chemical that's on the left side, okay? Limiting reagents are always on the left side of the arrow, so don't give me anything on the right side because by definition, those are products. They're not limiting reagents because they're not stuff we start with. Okay, so just a little hint for you guys. It's always going to be a chemical on the left side of the arrow. All right. Make sense? Pretty easy concept, right? It gets a little bit trickier as we start doing stoichiometry with it, but we're going to kind of ease our way into it. Okay, so let's move on. So we're going to do one more example with whatever makes you guys laugh a lot. But if you have 5 sausages and 3 buns, okay, what is the theoretical yield of hot dogs that you can make? Show me with your fingers. How many hot dogs can you make in this scenario? If you have 5 sausages and 3 buns. Yeah, same thing, right? You can only make 3, okay? Because theoretically, if I have 5 sausages and I didn't need to worry about anything else, how many hot dogs could I make potentially? 5, right? You can make 5 hot dogs, okay? And if you had 3 buns, obviously you can make 3 hot dogs if you didn't have to worry about anything else. But in reality, in this situation, you can only make 3 hot dogs. And it's because you're going to run out of which one first this time? Yeah, you're going to run out of Richard's favorite. You're going to run out of buns first. Okay, so if you guys notice, there were 2 options. You could have made 5 or you could have made 3. Okay, depending on your starting materials. But we chose the smaller number because what happens is you're going to run out of one of the reactants. So make sure you guys write this down. You're always going to pick the smaller number, okay? So you're gonna pick the smaller number. I guess smaller theoretical yield. Okay, because we could have made 5 because we had 5 sausages, and we could have made 3, but we choose the answer 3 because we're gonna run out of one of the ingredients before we get to 5, right? Once you hit 3, you run out of one of the reactants, and so we have to stop at the smaller number. And so that's kind of the point. That'll help you guys out once we start doing our stoichiometry. I know that with hot dogs and things like that, it's easy to kind of pick the right answer. But once we start doing Stoic where the numbers look a lot uglier, this tip will help you guys out, okay? Pick the smaller theoretical yield. What was that? Yeah, basically, how much you'll actually make. It's still theoretical yield because you're doing your calculations. Yeah. No, you still wouldn't make 4. I mean, we're using the term that we use for chemical reactions, but anyway, moving on. Okay, so your leftover is obviously going to be your 2 sausages. And so in this situation, the sausages are going to be your excess. Okay, make sure you guys jot that down somewhere. The excess now is not something you have so much of. It's whatever you have left over. Okay, whatever chemical you have left over, that is your excess. Okay. And so in your assignment today, you're going to have to do a bunch of Stoic. You're going to have to find the theoretical yield using multiple Stoic problems. You're going to have to find the limiting reagent and the excess. Okay, so just make sure you have a good handle on what we are talking about. Yes. You can't. You know, I wish you guys cared more about like your grade or something instead of these stupid definitions. It's not important. You guys make a big deal out of nothing. Okay, moving on. All right, let's combine this with stoichiometry now, where it gets a little bit more confusing, but should be manageable. So don't write this down. You have this in your, this is just here. You guys already wrote down what a limiting reagent is, but let's look at this problem. So if you guys take a look at this problem, it's the exact same problem we just did. We start with 100 grams of S. The only difference, though, is that we have 2 starting numbers now. Earlier, we did the problem if we had excess Fe, but now we're going to have 100 grams as our starting number. So when you approach a problem where you have multiple starting numbers, you're going to have to do Stoic multiple times. Okay, so earlier we did one of the Stoic problems where you have 100 grams of S. You set up 3 fractions. We did the stoichiometry, and then we found that it makes, what did we make? 274.5 grams of FES. This is the one that we did earlier, right? Okay, but now we have a second starting number. So what you're going to have to do is you're going to have to set up a second Stoic problem where you start with your other starting number, 100 grams of Fe. And what you're going to do is same thing. You're going to set up your 3 fractions. You're going to do your stoichiometry, and you're going to do the same thing where you're looking for FES. Okay, so earlier we started with 100 grams of S, and then we found grams of FES. This time you're using a different chemical, and you're going to find the same chemical at the end. Okay, so what I'm going to do is I'm going to give you guys 3 minutes. Try solving out this second one right here. Don't do the top one. We already did this for our warm-up. But I want you guys to solve this Stoic problem right here. See what you get at the very end, and then try to figure out what is the real theoretical yield of FES in this situation. Okay, so take about 3 minutes to solve out. That's the one on the bottom. Alrighty, guys, I'm going to start filling in the fractions. If you guys are still working on it, please feel free to finish up, but I'm going to start going over it. Okay, should probably finish around the same time. Okay, so on the top, we're going to do Gamimaga again. So our starting chemical is Fe this time. So we need to use some molar mass of Fe, which is going to be 55.84, right? Grams of Fe. We got 1 on the top. We got 1 mole of Fe on the bottom, 1 mole of FES on the top. And if you guys notice, this final fraction is the exact same fraction that we have up here, right? So we can just put in the exact same numbers, 87.84. Okay, next we're just gonna plug this into our calculator and then we are all done. So again, nothing really new going on here. Let's start with 100 divided by 55.84 times 87.84. That'll give us a final answer of 157.307. I'll round that up. As long as you got something close to that, that's totally fine. Okay, so before we finish up the problem, do you guys have any questions on how we got that answer? You guys chilling? Yeah. You're going to multiply the numbers on the top and divide the bottom. So 100 divided by 55.84 times 87.84. No, 100 divided by 55.84 times 87.84. So multiply the tops, divide the bottoms. Okay, so we have two different numbers for FES. And earlier we talked about how if you had different numbers, right, we could have made 5 hot dogs or 3 hot dogs. Okay, we picked 3 hot dogs. Why did we pick the 3? Yeah, we want to pick the smaller number. And so here, we want to pick the smaller number because what happens is we're going to mix S and Fe, right? But once we get to 157, we're going to run out of Fe. If you run out of one of the ingredients, you can't make any more of this chemical, right? Because you don't have the other one anymore. And so that's why even though we could have made 274, we're not going to get there because we're going to run out of Fe once we hit 157.307. So our theoretical yield is always the smallest number. I told you guys to write that down. So the real answer is going to be 157.307 grams of FES. Okay, always pick the smaller number for these calculations. And then the last part, the limiting reagent and the excess. Which chemical is the limiting reagent that we run out of? Yeah, Fe is going to be the limiting reagent. So make sure you guys jot that down somewhere. And then the excess is the one that we have left over. So what's the chemical we have left over? Yeah, S. So S is going to be our excess. So that is going to be our answers. Okay, so if you guys notice, the excess is on the left side as well. So your excess should also be on the left side of the arrow. So if you want to jot that down somewhere, you can. Excess will always be on the left side of the arrow. So limiting reagent is on the left side. Excess is also on the left side. Yeah. The what? You have to add Fe and S on the periodic table. Numbers on the bottom. Okay, so that's pretty much it for today. Yeah. Yeah, limiting will always be on the left. Excess will also always be on the left. You just need to figure out which one is limiting and which one you have extra. Make sense? Yeah, so if we want to kind of visualize this a little bit before you guys move on, this is one way you guys can think about it. We started off with 100 grams of S, 100 grams of Fe. We could have made 274, but we can't get there because what happens is once we get to 157.3 grams, we run out of Fe. So this guy runs out. That's what it means to be a limiting reagent. This one runs out. Okay, what that means is this guy is excess because we didn't use all of the S. So we're going to have some of the S left over at the end of the reaction. And so this is what we're going to learn how to calculate next week. So don't stress too much about it. We got more stoichiometry coming. But this is how we can figure out what the correct answer is. You always want to pick the smaller value. Okay. All right. So I'm going to give you guys the rest of the class period to work on your assignment. Let me know if you guys want to check your answers or if you guys have any questions. You will have some balancing. So just make sure you check the front of the reactions, but I'll give you the rest of the class period to work. All right. Good luck, guys. A what? Yeah.